Okay, so again, a sequence is a list of numbers. Usually produced by a formula. The book says it this way: a sequence is a function whose domain is a set of positive integers. Whoa, what does that mean? Now each individual entry, okay, is called a term. So you're going to have like the first term, second term, third term, fourth term of a sequence. Okay? All the way up to the nth term, if you will. Each term has a counter, and that counter is called the index. Okay? Now the index is the number that you plug into the formula, and here's a very simple example. Okay, so we want to list the first 5 terms. So a general formula says a sub n equals n. Okay, so if we want the first 5 terms, then we want a sub 1, and that just equals 1. A sub 2 equals 2. A sub 3 equals 3. A sub 4 equals 4. And a sub 5 equals 5, right? That's about as easy as it gets, okay? Now, let's look at the others, sequences in example 1, and let's generate those first 5 terms. Okay, so if b sub n is 2n, then I want b sub 1, which is what? 2. Wow, that really is a b sub 1, believe it or not. Okay, then we want b sub 2, and that is, what's b sub 2? 4. Yeah, don't complicate this. B sub 3. B sub 4, and B sub 5 is 10, right? So whatever n is, you times it by 2 for that one. All right, let's look at C. So C sub n. So we have C sub 1 is, it's negative 1 to the first power over 1. So that gives me negative 1. What about C sub 2? Okay, it's negative 1 squared, which is 1 over 2. Okay, what about C sub 3? Negative 1/3, correct. Because negative 1 to the third is negative 1. You're back again? I thought I was done with you today.
I forgot to turn in my review.
Nice. Yay.
Until next week.
Have a great weekend, Em.
You too. See ya.
Bye-bye. Okay, C sub 4 is?
Positive 1/4.
Very good. And C sub 5 is? Negative 1/5. Okay. Easy enough? All right. Now D sub n is an exclamation point. What does that exclamation point stand for in mathematics? It doesn't mean I just say "and" really loud, right? What's it called? I just heard it. Factorial. Okay, that's the exclamation point. You're about to. It's on our little box on the right here, okay? So now n factorial is just a short way of writing a product of numbers, okay? So basically if I have 5 factorial, for example, that is simply 5 times 4 times 3 times 2 times 1.
And it just goes down?
Yep, goes down to 1. Obviously it can't go to 0 because then it would always be 0, right? Okay, so guess what 4 factorial is? 4 times 3 times 2 times 1. 3 factorial. 3 times 2 times 1. 2 factorial. 2 times 1. 1 factorial. Yeah, this is 1. 0 factorial. Actually, by special definition, 0 factorial is equal to 1. There you go. 2 factorial is 2. 3 factorial is 6. 4 factorial is 24. 5 factorial is 120. Very good. Okay, so we just did the first 5 terms there, right? So D sub 1 is 1. D sub 2 is 2. D sub 3 is 6. D sub 4 is 24. And D sub 5 is 120. Those are the first five terms of that sequence. Okay? All right, now a little more complicated but still doable. Okay? So number 17 here, I want the first 5 terms again. So A sub 1 is Yeah, it's 1 over 1 plus 2, or 1/3. A sub 2 is 2 over 2 plus 2, or 2 over 4, which is, as was said, 1/2. A sub 3, 3/5. A sub 4, 4 over 6, which is 2/3. Good. And A sub 5 is 5/7. Okay. All right, number 25 here. So B sub n is n over e to the n. B sub 1 is what? Just plug 1 in for n's. It's 1 over e, right? Don't complicate this. It's 1 over e. What about B sub 2? 2 over e squared. B sub 3.
Do you want us to put it in decimal?
No. Not unless it specifically tells you to give a decimal approximation. Otherwise, we want it in exact form. So B sub 4 is 4 over e to the 4th. And B sub 5 is 5 over e to the 5th. Okay, so not only with generating the first 5 terms of formulas, of sequences, okay, we also need to be given a sequence and come up with a formula. Okay? So we look at example 2 here. We have 1/2, 2/3, 3/4, 4/5, 5/6. Okay, so we know that A sub 1 is 1 over 2. A sub 2 is 2 over 3. Now we want to go to A sub n is n over n plus 1. Very good. Because each term, okay, each corresponding term has the corresponding number on top and one more than that on the bottom. So n over n plus 1. Okay, let's look at B. Okay, so what is B sub n going to be? Okay, it's 1 over, right? Because the tops are always 1. Now my bottoms are what? I start with 3, and then I go, I'm timesing each term by 3. So how do I represent that then? 3n, exactly. Okay, what about part C here? 1 over 2 times 3, and then 2 over 3 times 4, and then 3 over 4 times 5. So C sub n is, what's on top? N over n plus 1, n plus 2. Good. That's exactly right.
Basically, if you can't figure anything out, you can just do n plus whatever you want to. I don't know, it might not work every time.
Yeah. I mean, you'll get good at it. I mean, you'll see where there's some definite patterns going on and stuff like that for sure. So, yep. Okay. So let's continue on. If you were given any of the formulas above and were asked to find the 100th term, it would be fairly simple. Correct? So what is the 101st term for problem 17? So in other words, I want A sub 101. And that's 101 over 103, right? Easy. So to find any term with those kind of formulas is pretty simple. Okay? Now occasionally there are other types of formulas that are useful. Okay, and these formulas are called recursively defined sequence. A recursively defined sequence. Recursive is the key word there.
What does that mean?
Okay, now it means this. Okay, a recursive formula. Now, a recursively defined sequence uses previous terms to define the terms that follow. So our second term is going to be dependent upon our first term. Our 8th term is going to be dependent upon our 7th term, and maybe even our 6th term. Okay? So here's what you have to be given. Okay? You have to be given your first term, or the first couple of terms, depending, and a formula to get from one term to the next. Okay? So here's what so if you look at example 3 here, that's what a recursively defined sequence looks like. So we're given the first term. So we're given a sub 1 is 3, and then we're given the recursion formula, which is a sub n equals 4 times a sub n minus 1. Okay? Now, let's talk about a sub n minus 1 for a minute, that notation. Okay? That means, basically what that means is it means previous term. Okay? So if I want to find a sub n, or a sub, well, okay, let's back. If I want to find a sub 4, for example, okay, then in this case, a sub 4 is going to be equal to 4 times a sub 4 minus 1, or a sub 3. So in other words, to find a sub 4, I have to know what a sub 3 is. Okay, et cetera, et cetera. Okay, so now...
4a minus 1 is saying the same thing as 4a3.
Yes, if I'm wanting the fourth term. If I want the fifth term, it's 4 times the fourth term. If I want the 12th term, it's 4 times the 11th term. Okay? So if I want to generate the first 5 terms here, okay? So we already know the first term, that's given to us. Now the second term is simply 3 times the first, or no, sorry, 4 times the first term. Yeah, or 4 times 3, which is 12. Okay, the third term is 4 times the second term. See where we get n right here and n minus 1 right there? So what's the second term? 12, so the third term is 48. Okay, my fourth term is what? 4 times the third term. And the third term is 48, and 4 times 48 is? Okay, what's my fifth term then? It is 4 times the fourth term. So it's 4 times 192, which is? What is it? 768. There you go. There are your first 5 terms. Okay? Now, here's the deal. A recursive formula works best when you want to generating terms. Okay? If you want to generate the first 5 terms, the first 7 terms of a sequence, a recursive formula is best. Otherwise, if you're just finding the nth term, if you want to find the 70th term or the 65th term, okay, the other types of formula works better. Okay, so again, so let's work with, now on example 4 here, we want the first, now it wants the first 7 terms here. Okay, so now the nice thing here is we're already given the first 2 terms. So we know a sub 1 is 1. We know a sub 2 is 1. Now what is a sub 3? A sub 3 is, now notice, it's a sub n equals a sub n minus 1 plus a sub n minus 2. So then a sub 3 is equal to a sub 2 plus a sub 1. So what does that equal? That equals 2, correct. Okay, and then what does a sub 4 equal to? That's equal to, so again, n is 4, so n minus 1 is 3, and n minus 2 is 2. So a sub 4 equals a sub 3 plus a sub 2, which is, 2 plus 1, which is 3. Okay, what about a sub 5? That equals a sub 4 plus a sub 3, or 3 plus 3 plus 2, which is 5. Okay, what about a sub 6? That's a sub 5 plus a sub 4, which is 5 plus 3, which is 8. And then a sub 7 is a sub 6 plus a sub 5, which is 13. Anybody know what sequence that is? That's a famous sequence, by the way. It's so famous it's got its own name. Named after the guy that did it, and it does start with an F, correct? No. Yes, okay. Everybody hear Sierra? Probably not. She's pretty quiet. It's called the Fibonacci sequence. There you go. Yep. Yeah, something like that. Okay. All right, so now a sequence is simply a list of numbers, and a series is a list of numbers that have been added together or summed. Okay, that's the difference between sequence and series. Sequence, we just list the numbers according to our formula. A series, we're going to add them up. Okay? Now, so in example 5 here, we want to write out these sums. Okay, now this little goofy letter you're going to see is the summation letter. Okay, and it's a Greek letter for sigma. It's like a capital S. Okay, that's a capital letter, Greek letter, sigma, which means sum. Okay? So, in this notation here, this means we start with the number 1 and we end with the number 5. Okay? So what I have is I start with k as 1. So I have 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5. That's what that means.
Where
So
did you get that?
from all that, right, from this 2k right here. So the sum, so I want the sum from k is 1 to 5 of 2k. So I do 2 times 1. Then I add that, and then sum means add, so plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5.
Where are you getting 1, 2, 3, 4, 5?
Because it's right, it's the k thing right here. Right? It starts out, the bottom one says what k starts with, and the top number up there says what k ends with. So we start k with 1 and we end it with k is 5. And we take each of those integers, instead of numbers I should say integers in between, okay, and then add them all up. So we get 10, 20, 30. So that is equal to 30. 30.
So that's like what you did right here. But
Uh-huh.
instead of times and you're adding.
Right. Very similar to that. You're right, Lisa. Okay? All right, so now let's look at part B. Now we go of n from 1 to 6 with 3n minus 7. So we do n is 1, and what do I get? If n is 1, I get negative 4. Plus, what about if n is 2? I get negative 1. Plus, n is 3. N is 4. N is 5. And then n is 6. So we add all those up. So we add negative 4 plus 1 plus 2 plus 5 plus 8 plus 11. So it's 10, 20, 21. And there's your sum. Okay. All right, 51. Now, notice k goes from 1 to n. Okay, so we don't know where it ends. All right, so here's how this looks. Now we have to write this out a little bit. So when k is 1, I get 1/2 plus when k is 2, I get 4 over 2, which is 2. What about when k is 3? 9/2 plus when k is 4, we'll just do one more. We get 8 plus plus, or sorry, no, not k, it's now n, because it's n. Plus n squared over 2. Okay? That's what it looks like when we don't have a defined number of terms. So you write out the first 3 or 4 terms, and then write the nth term.
Okay.
Okay? And that just means you replace k with n.
So you can't find the real sum.
Correct. Until we know what n is, we can't find the sum.
Okay.
Right? Does that make sense? Because we could make n 1 or 2 or 15 or 9 billion or whatever. Okay? All right.
Will we ever have high numbers for n? Or just, so we have to do it forever?
No.
Okay.
Well, yeah, okay. Let me back up. There are infinite sums and
Oh,
infinite
something
sequences,
more,
but the nice thing about it, there's a nice little formula for that.
Oh, good.
And it's also, and that's on your formula sheet as well. We'll get to that in future sections though, not today. All right, so now let's see what we can do here with example 6.
The E.
Yes, sigma, oh my gosh, time. Okay, hopefully be able to help you out. All right, so everybody look at example 6A. Okay, so we have 1 plus 2 plus 3 plus plus 40. Okay, So we need to come up with a rule for sigma in sigma notation. So there's sigma there. So we're going to go k equals, and we're going to start with 1, and then we're going to go up to 40. Now, what do I put over here? Or what? Okay, you can't see that. Sorry. Okay, so shoot. Okay, hang on. Yeah, we're going to do this on the board. Okay, so after we have our summation here, we know k goes from 1 to 40, and we've got to put a variable right in this area here. And in this case, since each term just goes up, or each number goes up with its corresponding term, it is simply k. Okay, now if we look at part B, we want to do our sigma notation, all right, and we always start with k equals 1. Okay, now in this case, since we go up by 2's and my last term is 38, I'm going to have 19 terms, and then the number out here is just going to be 2 times the term. When k is, so in other words, the first term is 2, the second term is 4, third term is 6, so we're always doubling the term to get our value. Okay, now on part C here, again we're going to start with k as 1. Now, how many terms do we go? Notice we got our first term is 1 up top, our second term is 2, and et cetera, et cetera. So our last term is 13, so we have 13 terms. Now, what goes on the right here? Well, again, notice the numerator is just simply whatever term we are, and the denominator, we add 1 to that term. So this one will simply be k plus 1, and that gives you your sum. All right, now we're going to talk about some formulas that we need in order to come up with the sums and sequences, okay? So the first one, now if we look at 7a here, we have k goes from 1 to 4, but our term is always 6. So basically what we're doing is this, we're adding 6 together 4 times, which gives us 24, or it gives us 6 times 4. Okay, so now part B, we are doing -5 8 times, which gives us a sum of -40. Now on part C then, okay, to expand those two into general terms, if I have k from 1 to n of C, then my answer is simply C times n, and that's the first formula that you need to know. Okay, now several other formulas that are in the book, okay, which you guys don't have, which is why we're doing this, so I'm going to write these down for you. All right, and they are as follows. So if I have the sum from k equals 1 to n of k, then that equals n times n plus 1 all over 2. And we'll show you how to do that one we'll show you how to do all these on part D here. Or this one on part D. The others we'll do on the next problem. Okay, so the next one we want, so k from 1 to n of k squared. Okay, and that equals n times n plus 1 times n plus 2 all over 6. Okay, and the last one that I want to give you for this is k equals 1 to n of k cubed. Okay, I'm going to write that down below here, and that equals, and it's a lot similar to k, n times n plus 1 over 2, but then we have to square it. All right, so now let's look at part D here. So now we have k from 1 to 1,000 of just k. Now if we were trying to do this by hand, we'd have to go 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way up to 1,000. All right, but instead now we can just use this formula right here. So we get, so we know k is 1,000, or excuse me, n is 1,000, so we get 1,000 times 1,001 all over 2. And then you can simplify that out. I don't need to punch that in a calculator for you. All right, now let's look at these other sums here. So here on part A, we have k squared. All right, so we look at our k squared formula up here, And we know in this case n is 10. Okay, so we have 10 times 10 plus 1 times 10 plus 2 all over 6. Okay, and so for this one, we just go, 6 goes into 12 twice, and then 10 times 11, 10 times 11 is 110, times 2 is 220. You know, part B is k cubed. So that, and again, n is 8. So we get, that equals n times n plus 1, which is 9. Oh, and n is 8, gosh. So 8 times 9 over 2, and then we square that. So we get 36 squared, whatever that value is. Again, you can plug that in. Okay. Now, if we have a number with a constant, then what we can do is we can take this number and we can put it out front. Okay. So this just becomes 3, and then we have c times n with that one. Is all you have to do there. Okay, and then the same thing with that 2, we bring it out front. Okay, so now this part D is the same as the other part D here, except for it's 2k instead of that. So we'd have, I guess I should have got a number for that. We have 1,000 times 1,001 over 2, and then we times that all by this 2 right here, by 2. So those 2's would cancel out, and you get 1,000 times 1,001. And that's how you figure out that sum.